Okay, I'm back. Coffee in hand. Okay, we were going to actually interpolate between the Y positions. Okay, so what we can do, this is not such a difficult task. What we need to do now is process both sound file players. Sound players. +1. Process. And we'll need to clamp this again. Oh, here we have a problem. If we try to clamp this, we'll process it a second time. And what that means is we'll skip every other sample, which will make it, if we're on this third sound, or the fourth and final sound file, it will skip every other sample and be twice as fast, therefore. So we can't do that. What's the solution? We'll have to do a check. If Y position greater than or equal to 3, or let's do less than or equal to 3, less than 3. Process the next one. And let's see. Well, let's scale the sample value. Sample. Let's make a couple extra variables. Float sample 1 equals this. Times. Let's see. This will be the Y position minus the truncated version, 1 minus the Y position minus truncated Y position. So if the Y position is 1.3, this will be 1.3 minus 1, which is 0.3. And 1 minus 0.3 is 0.7, so this will get the larger amplitude value. And similarly, float sample 2 equals sound players. It's the same thing. Well, no. Int Y position +1 get sample times Y position minus int Y position. Okay, so if that was 1.3, this will be multiplied by 0.3. This will be multiplied by 0.7, this will be multiplied by 0.3. So it will be louder the closer to the sample you're closest to. Alright, so we have the same issue of this being able to leak over the edge of what we actually have. So we need the same if statement. If Y position is less than 3, we can do that. If it's not, we'll still make a sample 2 equals sample 1. It's a little redundant, but sample 1 times y position minus int y position. So when this gets scaled together, the sample 1 position is 0.7 times plus sample times 0.7 plus the sample times 0.3. So it's the same thing it would have been. So when we come here, we don't need to get this anymore. We just need to add them together. Sample 1 plus sample 2. And we'll take that value, this mixed value, times the amp. Well, that's strange. No, why would I want that? Don't want that at all. Okay, so this is, I've made this a local variable. What I need to do is float sample 2. Now we have a higher level access to it. And this mixed value will be scaled by the amplitude and scaled by the window position. So that should be enough to do that interpolation. It won't, though. We haven't, or have we? Let's go to our update function. We have set y position. So the slider should interpolate now. Okay, so I shouldn't have closed that. You might have already noticed we're getting clicks and pops when we move that value. Note that this control rate, the update rate here is 30 or 60 frames per second. Is the refresh rate of the openFrameworks application. That is not at the same rate as the audio thread, so we're getting these sudden jumps. Hear that fuzzy pop and click here. Actually, let me double check that you're actually hearing that. You are. Okay. So that's an issue. That's also. There we go. So I'll link above, top right there, the tutorial about smooth values if you're interested in going in depth there. But y position needs to be a smooth value, not a static value. Or sorry, not a standard float. So we could put a smooth value inside the grain, but note that we'll have now we have 64 total grains possible. We'd have to have 64 smoothing values, and it seems that we could instead just pass in a smooth value, and every grain will get that. That should be a more efficient way to do this. So let's make that here. This Y location will be the target, and we'll still need that slider. Let's make smooth value. We'll call this smoothed Y location. A little wordy, but okay. All right, I believe that's how this works. And then I'll copy that. Go to our setup, and I'll do this after we make that. That way, the target will be the same. I'll explain that in a moment here. So smooth. Whew. All right. Dot smoother equals new parameter smoother. And this is covered in that tutorial I mentioned. And we'll give this a time of 20 milliseconds. This is fine. All right, smooth dot target value equals smooth y location dot current value when we set it up equals, this is just the way of setting them both in one line, and this will equal y location. So now, instead of in this update function sending this out, we won't do this here. We'll have to do that in the audio thread. What we will do is set the target value, so we don't need to do that per grain. But we will in the audio thread. So do we want to send that over 100 or 64 times? That's what we'll do for now. Make it work and then make it better. Okay, so what we need to do is set the target value. So y dot, target value. That target value will equal the y location slider. So it's not setting the value, it's just setting where it wants to be. Alright, we go to our audio thread, and we'll just update this every tick. So y, this dot current value equals our smoother. The smoother will process our target value. And that's how that's done. That's a big old line, but now our current value is smooth. Whoops, I forgot the process word. Oh, come on. Autocomplete's not helpful. Well, it is if you're better at this than me. Process target value. Okay, the y location smoother, the function of the smoother is process, and then the target value. And that's not even going to fit on one line just because I picked a long variable name, but I'm fine with this. Matter of fact, I don't need that window. Okay, so for every single grain, which is what we have here, we can grains set y position, and now we'll just set it with the current value, which is smoothed. And now we'll have no clicks. And you know, yep, that was all a waste. Sorry about that, but this happens to me quite a bit. The Y, that was clicking because it was happening mid-grain, but this position is decided at the very beginning of the grain and should stick throughout the life of the grain. So this was all just, I was just joking, guys and gals. Let's get rid of that. I'm just going to start using y'all instead. That's easier. Get rid of that. This was all, I was just kidding. All right, put this back. What we're going to have is like we did before. We're going to have a Y center because we will have stochasticity in this. Okay, so let's make sure it's back to normal. Okay, back to that normal clicking, and the problem is I'm allowing that Y position to change mid-grain. So where is that happening? It's happening here. So this y position internally needs to be static and set in the start function. So we'll leave it the way it is. We'll have a the way it is there. Let's go down to our variables, y position. So that'll be the y position used. We'll have a y position center, and that will be informing this. So that is what should actually be changed when we do this setter function. Center, is that what I called it? Okay. The y position center is set there, and y position for now will equal y position center. Oh, whoa, what happened? Okay, so now this is only going to be assigned when the grain is started. So we'll do this again and we won't have any clicks. It's a lot more efficient this way too. Okay, and let's address the fact that our X location is doing nothing. Go here, we'll adjust these X locations, grains, add I, set X position, X location. I don't think we have this in our grain class yet, so let's add that. We do not. So let's not even make the same mistake. Void set X position, float new X position center at the start this time. We'll need to make that X position center, and we'll need our static one, X position. Okay, and X position equals X position center for now. Okay, so where is this used? Or oh, we actually have a position value already. It's set here. So we'll just get rid of this. It doesn't need to be random. This we set at X position, which will be 0 to 1. And I think that's the only place we had to switch that. Did. Okay, so you notice, I'll close the right hand. Since we're covering over the same exact particle space, the same index of the sound file every time, we're actually getting a very pitched material, especially with a low duration. Let's make the left a little bigger so we can see where we are. close the right hand entirely. So we're basically freezing that moment of audio. This is actually, it's very slowly, this is a temporal method of time stretching. I can't move my hand that quickly, but I think that'll be a powerful way to use this tool when you're using your hand. It would actually be a little easier to be precise and slow, and actually like kind of scrub through a sound file in the X location, do a time stretch manually like that. But now our Y location is more of a timbral shift. Cool. So this is I think it was the moment it just became a relatively useful tool. Let's go ahead and have the left hand open and close. So we'll go to our evap.cpp. We'll pass in our grains at I. Set left hand spread, left open, which is the name of our slider. And I don't know if we have that yet. Let's check. Yes, we do. All right, so left hand spread. So now we need to set some stochasticity for these parameters. So when we choose the X position, we need to let's think about this. Plus or minus. Yeah, this would be easy. Where am I? Plus of random, negative, what do I call this? Left hand spread. Let's just do this. Left hand spread times negative 0.5 and left hand spread times 0.5. So if we're in the middle and our hand's completely open, it can play anywhere in the sound file. Note that I probably have a protection in the sound file player. If you try to play past where the sound file exists, I could check, or I could simply clamp this position to the boundaries. So of clamp 0 to 1. So now when your hand opens, you're not going to be pulling directly from the exact spot your hand is. You'll be pulling from locations near it. Let's do the same thing for the Y position. And I think let's reason this out. I think we want exactly the same thing. But with the Y position. So the the furthest that we'll go is within still the same two sound files. So you won't go, if you're directly in the Y position center, the furthest away you'll go is up one sound file or down one sound file. Okay, and that's with a full spread. So I think that's all we need to open there. Cool, and now the actual circle size will matter. And it's a fairly good representation of where in this sound plane, sound palette, that it will pull from. And obviously the unfortunate fact of using a GUI is that you can't really mouse click more than one at a time, which an important gestural part of this instrument is that you can do that. You actually can control with this gesture controlled synth, you can control every parameter at once. And obviously a huge factor of the sound of this synth is what sounds you put in. I mean, everything is almost entirely determined on what sounds are the source. So that would have to be chosen carefully. My plan is to kind of have a pattern. So like, you know, the textural stamp that, because you can't move from here to here without passing through these. So I'll kind of have a timbral plan on how I arrange these 4 sound files. Just depends on which sound file you call sound 1, sound 2, sound 3, or sound 4. Right now, you saw me pick them randomly from my hard drive. So right now, I've not paid too much attention to that. All right, and I've made the decision to, since this is coming from a center point on a stage, and this ensemble uses a point location, so this isn't coming from a set of stereo speakers on the stage. This should be a mono synth. It's coming from one sound location, non-hemispherical speaker. So there is not much point. I mean, it would be a little nicer to have a stereo spread, but it won't be a real tangible thing for the audience, and there's not a really a good way to control that with what I have so far with the 2 hands without adding a difficulty in control. So this will be mono. Let's see, what are our stretch parameters? I'm not going to worry about the tilt just yet. Currently deciding how, let's see. I don't think it will be that hard to have a reverb send. Let's do it. We've come this far. So the reverb I made for ofxATK is the standard, I think 1986, 1984 digital Schroeder style reverb. Just a series of not series, parallel comb filters and a series of all pass filters. 1 channel, so we're still in good shape because I just decided this is going to be mono. So let's add a reverb unit. I probably just call it reverb. Oh, that would be nice. It looks like I did. All right, let's set up that reverb. Reverb equals new reverb. I'm just gonna go with my stock parameters. All right. Let's add a slider for the reverb send. Oh, can't call it reverb. Let's call it reverb mix. That sounds good. And this won't be time or anything. This will just be how much of our sound are we. This is just the. Yeah, it's just a wet dry mix. So let's do 0.3 to start, 0.0 to 1.0. Okay, and come down. So current sample. I think it's reverb, feed, and process. Oh, and then we have to give it an input. So we'll give it the current sample. All right, so now we need to mix the two. So current sample, SMAPple, equals current sample this is the dry portion, times, so if the reverb is at 1, it's all reverb, so that would be 0. So 1 minus reverb mix plus reverb get sample times reverb mix. And I can tell already this is going to need to be a smooth value, but let's see if it was that simple to add reverb. I think it's good. Let's move this down to a more dynamic sound file. This is really tame that duration. Yeah, so it's kind of, you know, it's not great reverb, but it works. X location. You know what? I approached this the wrong way. You don't want to handle reverb like that, because if you pull away, it's going to give it an unnatural reverb tail. So ignore this. This was just some noob stuff right here. This should be the feed, so we can keep the slider the same, but we'll feed it times reverb. I just called it reverb mix. It shouldn't. I'm going to change the name. Feed. That makes it sound like it's a different input. But okay, it's a scalar value. That's all it is. Let's change that in the header. Change it here. And then we should be good. All right, so, and we'll always just add the reverb. So current sample plus equals reverb get sample. Now, when we pull the reverb back all the way, we'll still get the tail of everything that's been put into it. I'm curious. I think it's working the way I want to. I think I might have this reverb tail just insanely long. Not what I wanted. Again, I mentioned this in the previous part of this tutorial. If you know why jumping the definition works sometimes and not all the time, let me know. And if there's a way I can always just jump to the where it's defined, that would be great. So if you know that and you're watching this, please shout out in a comment. That would be appreciated. Okay, so when reverb's just made, the absorption's at, oh, I don't have it time as a variable. It's absorption. Let's just raise that a bit. In this reverb, there's absorption frequency, there's a mix, and there's a pre-delay. I'm just going to go ahead and just make it 3 times higher. That should tail it off quite a bit. Oh yeah, and you'll have to do this in your file, your reverb standard. You could actually just set these parameters yourself and play with these when you instantiate the reverb. I recommend it. This is commonly called freeverb these days. It's kind of interesting hearing the temporal implications of the duration, especially with that short duration. It is exaggerated by the reverb. One thing I'm going to change just for pure functionality, it's hard to control a gesture synth. You don't have a physical thing you're touching. It's kind of hard to know where you are. When the left hand's completely closed, you'll still need to be able to visually see where you are in those sound files. It'll be helpful. So let's go to this draw function where I just determine the size here. Let's just clamp that so the minimum can't go. Well, can I use I think it's fmin, or no, it'd be max, and between that, whichever is bigger, that or this is 10. I could use a clamp like I've been using, but this works the same. It's like a one-sided clamp. Well, it is a one-sided clamp. There we go. All right, so I think we're ready to add the leap motion. This has been a journey. I'm glad you have all come on this with me. So if you were there for the very first part of this tutorial, you'll know that I'll turn this down. We had a little issue with the library. I'm assuming it's on my end. So I'll record myself trying to fix the solution. If I think it's useful, I'll include it in the next part. Otherwise, this next part will just be adding the leap motion to control the synth.